the substance which we want to purify, that is volatile, and the impurities are non-volatile. In such cases, we can use the sublimation process. Once the impure compound is mixed with the solvent, we heat it and we get a saturated solution. We either keep it aside for a long time or else we filter it. Under distillation itself, there are different types, that is fractional distillation, steam distillation, and distillation under reduced pressure. Hello everyone, this is Ambali Unikrishnan from the Department of Chemistry, Vidhyaashram School of Excellence, Mysore. So in the last session, we studied about the different electron displacement effects in covalent bond, right? We finished the 4 electron displacement effects in the covalent bonds, right? And then we also studied the different types of organic reactions, right? So in today's session, we are going to study about the different methods of purification of organic compounds. So we are going to see how we can purify the organic compounds which are being prepared, right? So there are various ways or various methods in which we can purify organic compounds based on the type of organic compound which we are using, right? So the first one is distillation, then sublimation, then crystallization, differential extraction, and chromatography. So these different methods in detail we'll be studying today in today's session. So as said, these are the different methods in which we can purify the organic compounds. So purifying organic compounds means, yes, to remove the impurities which is present in the organic compound, right? So the removal of undesirable impurities associated with the organic compound is known as purification. Purifying something means what? Yes, removing the unwanted substances, or we can say unwanted impurities, right? To remove the impurities, that process is called as purification. And the various methods are distillation, sublimation, crystallization, differential extraction, and chromatography. And in some of these, under which also we have to study further methods as well. So let's begin with the first one, that is sublimation. Yes, so sublimation is a purification method. So you might be familiar with this word, sublimation. Yes, so that is the conversion of a substance from solid state to directly to the gaseous state without converting it through the liquid state. That is from solid directly gaseous state or gaseous state directly to solid state. It doesn't go through the liquid state, right? So now let's understand how this process happens. So the process of separation of volatile solids from non-volatile impurities on the basis of the tendency of the volatile solid to pass into the vapor state without melting is known as sublimation. So we use it in the organic compounds in which the organic compound or our substance is in volatile. It is a volatile solid and the impurities which are present, they are non-volatile. So volatile means they can get evaporated into the gaseous state, right? From solid state, it can get converted into vapor state. They are volatile. And non-volatile means they can't be vaporized. Right. So the substance which we want to purify, that is volatile, and the impurities are non-volatile. In such cases, we can use the sublimation process. And whichever substance you are taking, that they should be able to get sublimed. That means without converting into liquid state or without undergoing melting, it should get converted directly into gaseous state. So few examples for this volatile solids such as benzoic acid, naphthalene will be familiar for you. You have seen naphthalene balls, camphor, anthracene, all these are examples of substances or organic compounds which undergo sublimation. So how do we do this process? Yes, in a china dish, for example, we are taking ammonium chloride here. Yes, the organic compound that we have taken is ammonium chloride. Yes, and when we heat it with the help of a burner, what happens? As it undergoes sublimation from the solid state. Yes, ammonium chloride now is just in the solid state, right? So it gets from the solid state, it directly gets converted into the gaseous state without melting. And as you can see, there is an inverted glass funnel also kept. This is your china dish, right? And there is an inverted glass funnel which is kept. You're familiar with glass funnel, right? So it is kept inverted on top of the china dish. So what happens? The gaseous particles, that is ammonium chloride, it gets sublimed into its gas, right? And when it comes in contact with the walls of your glass funnel, it condenses, so when it comes in contact with the walls of the glass funnel, what happens? From the gaseous state, directly again it will come back to the solid state. So what you can see here, this part, that will be the solid ammonium chloride which is purified. Why? Because only ammonium chloride which is present here will be able to get converted into gaseous state. The impurities which is present here will remain here itself. Because why it is? Because it is non-volatile, right? Only ammonium chloride is volatile. The impurities will remain here. Ammonium chloride will get converted into gas. When it comes in contact with the inverted glass funnel that we have taken, when it comes in contact with the walls of it, it gets converted back into solid from the gaseous state. So it sublimates and we'll get the purified ammonium chloride on the inverted glass funnel, right? And we also keep a cotton plug on top of it. So this is how the sublimation process takes place. So this sublimation method of purification is not applicable for all the organic compounds, because it can be only used for those organic compounds which can undergo sublimation without melting or without going into the liquid phase, right? So the next method is crystallization. The impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at higher temperature. So what do we do first? We take the impure compound which we have to purify and dissolve it in a solvent in which it is sparingly soluble in room temperature. But once we increase the temperature, it will be completely soluble, right? So the impure compound is taken and then we add a solvent to it. Okay. Now the saturated solution, once it is saturated, on cooling or when allowed to stand for a long time, pure compound crystallizes out and is removed by filtration. Okay. So once the impure compound is mixed with the solvent, we heat it and we get a saturated solution. We either keep it aside for a long time or else we filter it. Okay, and once we filter it, we get the pure compound, right? And the impurities will be removed out. Okay, and the filtrate will contain the impurities, right? The filtrate will be containing the impurities and that will be removed and we obtain the pure compound. Yes, the impurities are present in the filtrate, it is removed and the pure compound is obtained. And now the crystals are formed, are removed, and they are dried. Okay, when we keep it aside for some time, we will be able to see the crystals forming and then later it is dried and we obtain it. Okay, so this is called as the crystallization method of purification. As you can see, the first step is, yes, the solvent is taken and it is mixed with the impure solid, right? The impure solvent and solvent is mixed. Then we evaporate it, that is we heat it. So what happens? Finally, we'll get a saturated solution. And as you can see in the dish, you will be able to see the crystals on the bottom here. Yes, and once we filter it out, we get the pure substance on the filter paper. The pure compound will be on the filter paper and the filtrate will be removed, right? That contains the impurity. If we dry the filter paper, we will obtain the crystals of the pure compound. So this is crystallization, right? Now the next method is distillation, right? Distillation method. The operation of distillation is employed for the purification of liquids from non-volatile impurities. So again, our impurities are non-volatile. They are non-volatile. That means they do not get converted into vapor phase. The impure liquid is boiled in a flask and the vapors so formed are collected and condensed to give back the pure liquid in another vessel. The non-volatile impurities are left behind in the flask. That means we take a flask in which we take the impure solid. That is our organic compound containing the impurities as well. As the impurities are non-volatile, when we heat this impure solid, when we heat it, the impurities will remain there because it is non-volatile. Only the pure compound will evaporate. And then what do? Using a condenser, we condense this gas into the liquid state and we obtain the pure compound, right? So that is what is happening. So from this diagram we can understand it. Yes, the impure solid will be taken here, right? And it is using a Bunsen burner, we are heating it. So what happens here? The impure solid is present. That is with the impurities. So now as our impurities are non-volatile, they'll remain here. Only the pure solid will start evaporating. Once it starts evaporating, now it will move through the condenser. So what is condensation process? From gaseous state, it is coming back into liquid state. Conversion from gaseous state to liquid state. So when it passes, now the gases of the pure compound, when it moves through the condenser, what happens? It undergoes condensation. From the gaseous state, it will get converted into liquid state, and finally you will just obtain the pure liquid substance. In the liquid state you will be obtaining. That will be the pure substance, right? The pure compound, and the impurities will still remain in this flask, right? So for few examples of compounds which we can purify using distillation are chloroform and aniline, and ether and toluene. So this is distillation process. So now under distillation itself there are different types, that is fractional distillation, steam distillation, and distillation under reduced pressure. Let's see that as well. So now depending upon the nature of the liquids and the impurities, one of the following distillation methods are used. So it is based on which is the nature of the liquid and the impurities. So based on the nature of the liquid and nature of the impurities, we decide which distillation process to take up, right? So the first one is fractional distillation. So this method is used for separation of liquids from the liquid mixture which have very close boiling point to each other, which differ by 15 to 16 Kelvin. Okay, so we use this fractional distillation method for a liquid mixture if both of them are liquid and both of them are volatile. That means both of them will get converted into vapor phase. So in such cases, when the boiling points are very close to each other, yes, if boiling point difference is there, we can easily separate them. If the boiling points are very close to each other, it will be very difficult to separate them. Yes, because both of them are volatile. So in a liquid mixture, the both liquids, when the boiling points are very close to each other, we use fractional distillation method, right? And in this method, vapors of the liquid mixture are passed through a fractionating column. It is fractional distillation, so that means they are passed through a fractionating column before undergoing the condensation process, right? So when the vapors of the two liquids move up, the vapor of the liquid with high boiling point condenses in the fractionating column, and only the vapors of the liquid with low boiling point passes through the fractionating column and gets separated. As I said, there are two liquids present which have very close boiling points with each other, and out of these two, whichever is having higher boiling point, it won't reach till the condenser and condense and form the liquid. So the one which is having higher boiling point, that will remain in the fractionating column and condense there, right? And only that liquid which is having the low boiling point will pass through the fractionating column and finally condense and form the liquid, right? So as we can see in the diagram, yes, there is a fractionating column as well, right? So here it is heated in the presence of an oil bath, and as you can see, both the liquid mixtures will be here, yes, and it will pass through the fractionating column. So the liquid with higher boiling point will condense here itself, and the liquid with lower boiling point, it will pass through the condenser, it will condense, and finally it will be present or separated as the liquid substance which is pure. So in this way you can obtain both the liquid mixtures separately or both the liquids separately, right? So this is fractional distillation, and this method is adopted when both the liquids which are volatile, both of them are having boiling points very close to each other, right? So the next one is steam distillation. So this method is used to separate liquids which are steam volatile, right, and immiscible with water. They might not be soluble in water, but they will be volatile or soluble in steam, right? So for such compounds we use steam distillation. When steam is passed through the heated liquid. The liquid vaporizes well before its boiling point and gets separated. The vapors containing steam and the liquid are condensed and then separated using separating funnel. Steam distillation is based on the principles of Dalton's law of partial pressure. Right? So as you can see, the vapors containing steam and liquid are condensed and then further they are being separated using the separating funnel. So this is used for the compounds which do not, that is immiscible in water, but they are steam volatile. That is why it is called steam distillation. So as you can see here, the substance or the compound which has to be purified is taken here, and when steam is passed through it and finally it goes through the condenser, what we obtain here will be the steam as well as the liquid, and then further it will be separated using separating funnel. Right, so this is steam distillation. Now the last one is distillation under reduced pressure. Now why we used distillation process under reduced pressure? Let's see. So this method is employed for the purification of organic liquids which have very high boiling point and they decompose it near their boiling point. Okay, so that means these organic liquids that we are taking, why we are doing distillation under reduced pressure is because of that they have very high boiling point. So before reaching their boiling point, they will decompose. So before reaching the boiling point, if they are decomposing, how do we purify them? So the distillation is done under reduced pressure. So in such case, what do we do? In this method, the liquid is made to boil at a lower temperature under reduced pressure than its normal boiling point by reducing the pressure. Right? So to avoid the organic liquid decomposing before reaching its boiling point, what do? We boil the liquid at lower temperatures. So to boil it at lower temperatures, we reduce the pressure. Right? So this method is opted for those organic liquids which have very high boiling point. Yes, and they decompose before reaching their boiling point. So what do? The distillation is done under reduced pressure conditions, right? So glycerol is separated from spent dye in soap industry by this method. This is an important example. And glycerol decomposes at its boiling point 563 Kelvin under atmospheric pressure, and it can be distilled without decomposition at 453 Kelvin under 12 mmHg pressure. So when we decrease the pressure, yes, under reduced pressure, if we are conducting this particular distillation, instead of 563 Kelvin, at 453 Kelvin itself, we can boil the liquid, right? So this is distillation under reduced pressure. Now next one is differential extraction. Differential extraction, which is done using a separating funnel, as you can see here, right? So the separation of organic compound from its aqueous solution by mixing it with a suitable organic solvent which is immiscible with water is known as differential extraction. So we want to separate the organic substance, any compound, organic compound, from its aqueous solution. That is, organic compound is present plus water, that is aqueous solutions. So we have to separate the organic compound from its aqueous solution. Yes, so what do is we mix it with the suitable organic solvent. Yes, we add an organic solvent to it. Yes, and we mix it. And this organic solvent must be immiscible. It should not be miscible with water. The organic substance we are taking, that is the organic solvent we are adding, that must be immiscible with water. So this method is employed for the separation of benzoic acid from its aqueous solution using benzene. So benzene is a solvent that we are adding which is immiscible in water. Organic layer is dried over suitable dehydrating agent for the separation of which depends on the nature of the organic compound. So as you can see in the diagram, this blue part is the organic compound in aqueous layer. Organic compound plus water is present. So to separate this, we add a organic solvent which is immiscible in this, right? So the yellow part you can see that is the organic solvent which is being added. Then we thoroughly mix it. Now what happens? The organic compound and solvent layer will be on the top and the aqueous layer, that is the water, which is immiscible, right? Now the water is immiscible in the organic solvent, but the organic solvent will be miscible with the organic compound that we have to purify, right? So the organic compound and the organic solvent will be in this green position now, right, in this area, and below that in a separate layer you will be able to see just the water. So now if I open this part, I'll be able to separate just the water, right? And once the water is removed out, we can just obtain the organic compound, and further we can dehydrate it and purify it. Yes, so I hope it is clear. So in the first step, what do we do? Yes, we take the organic compound which is present in its aqueous solution, right? Organic compound plus water, which you can see here. We add a suitable solvent to it which is immiscible in water, but it is miscible with the organic compound. So once we shake it thoroughly, we get the organic compound and the organic solvent layer here, and just the water will be separated. So now if I open it, the water will be removed out and we just get the organic compound, right? So I hope it is clear. This is differential extraction. Now the next one is chromatography. So chromatography, the word comes from the word chrome and graphy. Chrome means color and graphy means writing. So this is an important technique used to separate compounds of the mixture, to purify the compound and also to test the purity of the compound. Yes, for purification as well as to test the purity, how much pure the compound obtained is. For that also we use this technique. In this technique, the mixture has to be separated, is applied on a stationary phase. Usually silica gel or alumina is used, and a mobile phase is allowed to move slowly over the stationary phase. The compounds of the mixture gets gradually separated. So in chromatography, what you have to remember is there is a stationary phase as well as there is a mobile phase. So as the name suggests, stationary phase will remain stationary, right? And through the stationary phase, we'll pass a mobile phase. Right? So as the name suggests, mobile means it can move. So stationary phase will be there, and through that we pass a mobile phase. And based on different factors, we'll obtain the purified compounds. Right? So the stationary phase will be a solid or liquid, and the mobile phase can be a liquid or a gas. So the stationary phase usually taken, it is silica gel or alumina is used as stationary phase generally, and mobile phase is pure solvent or mixture of solvent or gas. So the mobile phase will be the one which we want to purify. So we take that organic compound which we have to purify as the mobile phase, and the stationary phase will be alumina or silica gel generally, right? So that is chromatography. Now there are different types of chromatography. One is adsorption chromatography. The next one is partition chromatography. So let's begin with the first one, that is adsorption chromatography. Now it is based on the principle of different compounds are adsorbed on the adsorbent to different degree. Okay, so the stationary phase is called as the adsorbent and the mobile phase is called as the adsorbate. Okay, so where the adsorption is taking place, that is the adsorbent, and who is getting adsorbed, that is the adsorbate. Yes, adsorbent and adsorbate. Okay, so it is based on to what extent adsorption is taking place, to what extent the adsorbate is getting adsorbed on the adsorbent. So it's based on the extent of the adsorption which is taking place. So that is why it's called adsorption chromatography. Now in adsorption chromatography, there are two types. The first one is column chromatography. So as the name suggests, we'll be doing it in a column, right? The column chromatography is based on a column. Now in this method, the mixture to be separated is placed in a column as shown in the diagram. See, so the mixture we have to separate, it will be taken in a column. Now, and the liquid which is called as eluent, the liquid is allowed to flow down through the column. Now, different columns are formed depending upon the degree to which it is absorbed. right? The most readily adsorbed substance is retained near the top and remaining substances move to different points in the column. So what does that mean? Let's see. So as said, there will be a column and we take the mixture of compounds. Let's say there are 3 compounds in here, A, B and C, and we have to separate A, B and C from each other. Now what you can see here is a mixture of A, B and C. Right? So that is our organic compound which we have to purify. Now, through the column, we pass a suitable solvent. So as you can see, the solvent is here. Now it is passed from the top of the column. So now what happens? It will flow in this direction. Right? And this is the adsorbent, that is your stationary phase, and the solvent will be the mobile phase. So now what happens? The mobile phase will pass through this mixture and it will go to the stationary phase. Yes, the solvent layer, it will move, but the stationary phase will remain as it is. Okay, now based on the extent to which each of these components, that is A, B and C, it's based on how much extent it can get adsorbed, you will be able to see it in different layers. So as you can see, first you are able to see that A got separated. Now B and C is together here. Right. Now after a while what you can see, this layer is of A, this column is of B, this column is of C. Now you got it separately. Yes, each of the compounds are separated. Now, based on what it is, based on the extent of adsorption. So, A is present on the topmost part. That means A is getting the maximum adsorbed. Maximum adsorption means it won't be moving too far, right? It is getting adsorbed there in high. So, the adsorption power is more, means A will remain here. It won't go further down, right? And C will be the least adsorbed. That is why it has reached till here. So, based on the extent of adsorption, we will be getting different columns. Yes, so this is how column chromatography works, right? Next one is TLC, that is thin layer chromatography. TLC stands for thin layer chromatography. In this method, a thin layer, that is of 0.2 millimeter thickness of adsorbent is spread over a glass plate of suitable size, and that is known as the chroma plate. So as you can see, there will be this, as you can see, is a thin glass plate of around 0.2 millimeter thickness. It's a very thin glass plate, and on which the adsorbent will be spread over. Adsorbent mean which is our stationary phase. That will be spread over this thin glass sheet, right, or glass plate, and that is called as the chroma plate. That's the first step. A small spot of the mixture is placed about 2 cm above at one end of the TLC plate. So now this is our TLC plate, and now it is kept inside this. So now from the surface above 2 cm, we place a small dot of the mixture. Right, the mixture we have to separate. We'll keep the TLC inside this, and about a 2 cm from the surface, we put a dot of the mixture, right? And then inside this, where we have dipped it, there will be a solvent also present. So the one end of TLC will be dipped in this solvent. So what happens? So now based on the capillary action, the solvent will start moving up. So once the solvent will start moving up, it will pass through this mixture, right? So when it passes through this mixture, this is our stationary phase. The solvent will be mobile phase. So when the mobile phase, that is solvent, it is moving, it will pass through this particular point, and the mixture will start separating based on its extent of adsorption. Yes, so the plate is placed in a closed jar containing the eluent, that is, a solvent is used for the separation of components. Right, so it is placed in a closed jar in which the solvent is present, right, and the solvent is drawn up the adsorbent layer by capillary action. So by capillary action, when the solvent is moving up, it takes up the mixture as well, and it will separate the different components based on its extent of adsorption. So you will be able to see something like this. So if there are many compounds in which red, purple and blue, and this is your solvent, and this is the origin. Yes, 2 cm from the surface we put the mixture, right, which has to be separated. So the red came till here, and the purple came till here, yes, and blue here, and this is your solvent, which was initially here. The solvent reached till here, right? So based on the extent of adsorption, you will be able to get different compounds separated, right? So there is an important factor here as well, as that is retardation factor, which is represented by the letter RF, right? So it gives the relative adsorption of each component of the mixture, and it is represented by the symbol RF, which is equal to the distance moved by the substance from the baseline X and divided by the distance moved by the solvent from baseline Y. That means if this is the origin, from the origin, how much distance your substance has traveled divided by how much distance the solvent has traveled. So let's take the case of purple. Okay, I have to find out the extent of adsorption or relative adsorption of the purple substance. So RF will be equal to how much distance the purple has traveled from the initial or origin state. It is 8 centimeter. As you can see, it is 8 centimeter. So 8 divided by how much distance the solvent has traveled. How much distance the solvent has traveled? 10 centimeter. So 8 by 10 centimeter will give you the retardation factor. So that is how you calculate the retardation factor. So for whichever substance you have to calculate the retardation factor, the distance traveled by it divided by the distance traveled by the solvent will give the retardation factor, right? Yes. Now moving on to the next type. The first one was adsorption chromatography. Next one is partition chromatography, in which we have to study paper chromatography. Yes. So what is the partition chromatography? It involves continuous differential partitioning of compounds of a mixture between stationary and mobile phase, right? And the important one which we have to study here is paper chromatography. So paper chromatography is actually quite similar to TLC, that is your thin layer chromatography. The same way we do it, but instead of taking a chroma plate, that in TLC we used a thin sheet of glass, right? So in this case, we'll be using a paper. That is why it is called as paper chromatography. So in this method, a spot of the mixture is placed in a special type of chromatographic paper which contains water trapped in it, right, as in the case of TLC. Now this paper strip is suspended in a suitable solvent, and depending upon the selectivity, different compounds are separated, and this paper strip is known as chromatograph. So instead of taking a thin sheet of glass, we take a paper which is a special paper which is called as chromatograph, right? The paper strip we take, and the same way we put it inside a closed jar in which we have a suitable solvent, right? So the solvent will be the mobile phase. So when we are dipping a paper, what happened? Yes, capillary action will take place. The water will start, that is the solvent will start moving up. Yes, so the stationary phase will be your paper strip and the solvent will start moving. That is the mobile phase. So as it moves up, the different components will be separated. So it is quite similar with TLC. It's just that we take a paper strip here which is called as a chromatograph. So as you can see here, in the paper strip will be dipped in a suitable solvent, and when the solvent starts moving up, so this is where we have initially taken the mixture that we have to separate. So, and it is dipped inside the solvent. So now what happens, as the solvent will start moving up, the different layers will be separated. So you can see the different individual pigments. In this particular example, we have taken a particular ink spot, right? In a particular ink, which in all color is present. When we dip it in a particular solvent, what happens? As the solvent moves up, we will be able to differentiate or get the different compounds, that is different pigments based on their partition or adsorption happening there. So I hope it is clear. So in today's session, we discussed about the different methods of purification of organic compounds, right? So I hope it is clear for everyone. So in the next session, we are going to discuss the qualitative analysis of organic compounds and the quantitative analysis of organic compounds as well. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.